Hey, welcome to The Explainer. Today, we're going to look over a developer's shoulder at what seems like a totally normal app. But, hidden inside is a security flaw so bad it could let literally anyone take over your account. And the cool part, you don't need to be a programmer to spot it, because we're going to use AI to uncover all the secrets hidden in the code.
Okay, let's dive right in. So on the surface, you've got this perfectly normal web application. It lets you update your profile. It seems to work just fine. But, and this is a big but, lurking just under the hood are some really critical security flaws. Flaws that could lead to a complete and total account takeover. So, our mission today? We're gonna find them.
All right, here's our Exhibit A. It is a super basic profile update form from a web app. You type in a username, a new email, a new password, you click that update button, and boom, it saves your changes. I mean, this is the kind of thing you've probably used 1,000 times on countless websites, right? And the tech behind it? It's just as common. On the back end, that's kind of the brains of the whole operation on the server. It's using Python with a really popular framework called Flask. The front end, the part you actually see and click on in your browser, that's just standard HTML and JavaScript. And all the data gets stored in a simple database. This whole setup is used all over the web, which is exactly why figuring out its hidden weaknesses is so important. Okay, time to switch gears. To find these hidden flaws, we've got to stop thinking like a regular user, or even like a developer. We need to put on our hacker's hat. We've got to start looking at this simple form, not for what it's supposed to do, but for what we could force it to do. And wow, once you start poking at it, the whole thing just falls apart. It's not just one little mistake, it's a whole cascade of failures. You've got the huge ones, like zero authentication and storing passwords in plain text, which is just wild. But then there are others like no input sanitation, which means a hacker could just inject malicious code right into the app. Or no CSRF protection, which could let a totally different website trick you into changing your password without you ever knowing. Every single one of these is like an open door for an attacker. Let's start with the absolute biggest one, no authentication. What this means is the code that updates the profile, well, it never actually checks who is sending the request. It just grabs the username from the form and updates the database. So think about this. I could just submit that form with your username, pop in a new password of my choosing, and just like that, I've locked you out and taken over your entire account. Next up is a classic, and I mean classic, critical mistake, storing passwords in plain text. Seriously, this is the digital equivalent of writing your ATM PIN right on your bank card with a Sharpie. If a hacker ever gets a copy of that database, they have everyone's exact password. A secure app, on the other hand, stores a hash, which is like a one-way mathematical fingerprint of your password that simply can't be reversed. This all really comes down to the hacker's mindset. To be a secure developer, you have to be a paranoid developer. You have to assume every single click, every keystroke from a user could be an attack. You have to assume the database will get leaked eventually. And that's why you build something called defense in depth. It's like having a lock, a deadbolt, and an alarm system on your front door. If one fails, another one is there to stop the intruder. Okay, so we've found the weaknesses. We've poked all the holes. But, pointing them out is the easy part. How do we actually fix them? Well, it's time to switch hots again. We're going from hacker to defender. We are going to fortify this app and turn it from a house of cards into a digital fortress.
Now look at this. The fix for that gigantic authentication flaw, it's actually surprisingly simple. In the secure code, we add one single line, @login_required. In Python, this is called a decorator, and it basically acts like a security guard. It tells the app, whoa, stop. Before you run any of this profile update code, make absolutely sure the user is logged in. Then, the code grabs the username from the secure session itself, not the untrusted form. Just like that, problem solved.
And it's the same story for fixing those plain text passwords. Instead of just saving the password directly, the secure code runs it through a generate password hash function first. This creates that secure one-way fingerprint we were talking about. Now, even if the database gets stolen, the attackers just get a list of totally useless hashes. They get nothing.
But we don't stop there. For true defense in depth, we've got to add more layers. For instance, we'd add CSRF tokens.
You can think of these as a secret handshake between your browser and the website for every single request. It prevents a malicious site from tricking you into doing things you didn't mean to do. We'd also enforce HTTPS to encrypt all the data as it travels, and add rate limiting to stop bots from just guessing passwords over and over. Every layer makes that fortress stronger.
Now, for years and years, spotting all these issues required a dedicated and expensive security expert. But that is changing, and is changing fast. The modern twist in our little investigation here is that you now have a partner in this process, an AI security assistant, that can help you find these flaws, like instantly.
And here's the best part. You do not need to be a coding genius to use it. The real key skill now is learning how to ask the right questions. You can pretty much treat a large language model like a junior security analyst. You just feed it some code and ask it to run an audit.
So, for example, you could give an AI this exact prompt. See how specific it is? You're not just vaguely asking, hey, is this secure? No, you're telling it exactly what to look for. Authentication bypass, password problems, XSS, CSRF, all the stuff we talked about. The AI can then scan that code and report back with a super detailed analysis, pretty much just like a human expert would.
You can also use AI to learn from other people's mistakes, which is incredibly powerful. This prompt asks the AI to act like a research tool. Go find real-world examples of a specific vulnerability. This is a fantastic way to understand not just the theory of an attack, but how it actually works out in the wild.
And finally, you can use AI proactively. Before you even write a single line of code, you can ask it to list the common security traps for the specific technologies you plan on using. This way, you can just avoid making those mistakes in the first place. It's a total game changer.
So, what have we learned from all this? What's the big takeaway from our investigation? Well, we took a seemingly harmless little app, we exposed all its dangerous secrets, and then we rebuilt it into something actually secure. And we saw how AI can help us do all of that way faster than ever before.
And really, here's the most important takeaway. Understanding the basics of digital security is no longer just for the experts. By knowing just a few foundational concepts, like why passwords have to be hashed, and by using these powerful new AI tools, anyone, and I mean anyone, has the power to ask the right questions and help build a safer internet for all of us. Which, of course, brings us right back to you. Your data, your profiles, your passwords, your private information, it all lives inside hundreds of different apps. So, after seeing just how easily a simple app can become a huge risk, how confident are you that your data is truly secure? That's definitely something worth thinking about. Thanks for joining me on The Explainer.